Hey, I'm Ben and welcome to Wood Dorking, which is what I'm calling this little area of the internet that I'd like to dedicate to the dorkier things that I do in my wood shop. Woodworking adjacent things. Not necessarily woodworking, but it makes my time in the wood shop more enjoyable. This first video, I want to dig into something that I'm pretty passionate about, and that is using CAD to create things in the computer and bringing them to real life. And while I don't like making doohickeys with my 3D printer, we're going to make a doohickey today, but this doohickey is very, very specifically designed for woodworkers. This is a mortising template. And not only is it a mortising template, it is a entirely parametric mortising template. So we're going to make this in Fusion 360, then 3D print it. I think it is a perfect thing to introduce parametric modeling, and it's a super useful thing to have in your shop and to know how to do. If you just want to steal the file that I create, that's fine. You want to take the easy route out, that's cool. I'm going to have a link in the doobly-doo to the file that we create, and it'll be a parametric file that you could change the dimensions on, and you can create your own mortising template from my file. But it'd be a heck of a lot better if you just create the file yourself, and you're going to learn a lot more that way. So let's dive in. The first thing I want to talk about is parametric. What do I mean when I say parametric? It's simply you create parameters and the computer uses those parameters to base everything else off of. A parametric modeling program like Fusion 360 is so powerful because if you change one parameter and the other parameters are related to that parameter, everything else can get updated. It creates a model that is fluid, if you will. So if you decided to make a cabinet and the door was based off of the width of the cabinet and you change the width of the cabinet, the door width is going to change as well. There are plenty of programs out there that do that, and there are definitely ways of making SketchUp, which is a very, very commonly found program for woodworkers. There's definitely ways of making SketchUp do that, but Fusion is like based off of that. It's bread and butter. And once you start thinking parametrically, or once your brain clicks, it's just about impossible to get away from that. I used to use SketchUp all the time. I love SketchUp. It's a great program. My mind doesn't want to work that way anymore. It's almost like Destin from Smarter Every Day with the reverse handle bicycle. If you know what I'm talking about, it just doesn't click anymore. But trust me, thinking parametrically is worth it. It's really, really worth it. So first things first, we need to think about the parameters that we need to set for a mortising template. And I have my little trim router here, and I have a bushing in that trim router, and I have a bit in that trim router. And this is a really powerful tool for mortising, especially when combined with something to guide them. My bushing, I almost always use a 3/4 inch bushing. It's like my default. And a 1/4 inch bit is a pretty powerful tool. So right off the bat, those are two parameters that we need: 1/4 inch bit, 3/4 inch bushing. When I think about something else, how wide do I want this base to be? I want it to hold my trim router nicely. So that's about 2.5 inches on either side. That's easy. And probably the most important parameter that we need, I'll stop making air quotes eventually. The most important parameter that we need is the size of the mortise that we want. Mortise width and mortise length. There we go. And then also it's good to have stops on your mortising template, and how far away from the edge of the board do you want that mortise, and how far away from the side of the board do you want that mortise. So the end offset and the side offset, those are pretty important too. So that's pretty much our laid out list of parameters. Let's jump into Fusion and do it. So here we are in Fusion, a brand new project. The first thing you always want to do is you always want to save your project. And Fusion gives you 10 slots to save in. But don't worry about that right now. You can make way more than 10 things using a personal license for Fusion. I have a personal license right now. If I wind up making money with this channel or with using Fusion, I will upgrade to a commercial license. But right now I have 10 slots to work from. That's 10 active projects. If you want to make those projects uneditable or archive them, if you will, you can easily do that. And you can swap projects in and out of the 10 slots all day long. I have hundreds of things that I've done in Fusion, but you have 10 active projects with a personal license. So starting right off, Fusion has sketches and bodies and components. Everything is based off of a sketch, and we're going to make bodies from those sketches. That's as far as we want to worry about today. So right off the bat, let's just mess around. Let's make a sketch. I'm going to click this plus button up here and create a sketch. And you can pick a plane to do the sketch on. I like to do everything from top down, so I'll just click that bottom plane. And right here you have your different, you can do a line or a circle or splines, mirror. In this menu, you have all of your variations and your options. We can just do a 2-point rectangle, and I'm just gonna do a couple rectangles, right? And hit escape to get back to the select tool. And there's the beginning of a sketch, really. So we could do that and move things around. And there's no sizes right now, and I have no idea how big this is. So I'm gonna hit D to get to my dimension tool, and that's 54 millimeters. And this one is 88 millimeters. And that's fine. I can't change anything about this rectangle because Fusion knows that this wants to be the same size as this, and this wants to be the same size as this. So that's kind of stuck, and that's not working parametrically. So let's right off the bat put some parameters into Fusion. And if you have known parameters, it's really nice to start with them. So go up to the modify window and click change parameters. I'm going to put in the parameters, but what are the parameters? We've got the bit and we've got the bushing. We're going to make up some mortise with parameters, things like that. So let's dive in. So right off the bat, we're going to click this plus button. And let's start with mortise width. And oh, it turned red. So it won't let me do anything. Like I can do 3/8 of an inch mortise width, but it won't let me save that. And that's strictly because Fusion does not like spaces in parameters. So I'm just going to get rid of that space. And I like to use camel case, just the first letter of each word gets capitalized. It's easier to see things since there are no spaces. So we're going to go with a 3/8 inch mortise width. Click OK. Make a new one. And we're going to say mortise length. And let's do 2 inches. And this is one thing to point out. So if you look right here, Fusion does not like working with fractions, but it'll let you put fractions in. It just does the algebra for you to make it 0.375. You don't need to type in 0.375, or if you want to type in 0.375, that's fine too. So let's do the next one. We're going to do bushing, and that one is 3/4 of an inch. And let's see what else. Oh, we need our bit size. Our bit is 1/4 inch. I'd like to just put a parameter in for how much meat we want on each side of the template so that our router is stable on that template. So let's say 2.5 inches. What do we want to call that parameter? Does this matter? No, this doesn't matter, but let's call it meat. And we're going to say 2.5 inches. Another parameter is the side offset, which I'm going to do 3/16. If we wanted a 3/8 inch mortise centered on a 3/4 inch board, we would need 3/16 on each side. And then let's do an end offset, and let's say 1 inch. And we're going to do one more parameter, and it's going to make sense, but this fusion requires a little bit of math sometimes, a little bit of algebra in order to make it function easily. And I just need you to know, I went to music school and I took as few math classes as I possibly could in high school and still graduate. So an immense math knowledge is not required to use fusion. But I'll give you the formulas for this one. But every now and then you might need to figure something out. It's not bad. It's not bad at all. But we are going to make a new formula just called offset. And this formula is going to be the distance between the edge of the bit and the edge of the bushing. Because the recess for that this needs to be bigger so that the bit can get to that outside of the mortise, right? So we're going to say, we're going to do bushing minus bit in parentheses, and then we're going to divide that by 2. So we're going to do bushing minus bit and then divide the whole thing by 2. And that's it. That's as complicated as we're going to get right now. So we're going to click OK, and we have our parameters in. Now I'm going to hit R to make a rectangle, and I want to make a rectangle that is the mortise width, and hit tab to get over to the mortise length. And that is the size of the mortise we want to make. I'm going to double click that and select the whole thing. And over here on our sketch palette, which may or may not be open for you, I want to switch that to a construction line. And there's a reason why, you'll see why, but we're just going to make that a construction line for now. And let's double click that. And I am going to go up here and offset it. So now that's the size we want, but we need to make that recess bigger for the bushing, or the offset of the bushing and the bit. So now I am going to offset that just as much as offset. And it's a larger hole now. So boom, we're pretty much there, right? That's a piece of cake. Right now we have that hole, and I'm going to do this one square. When I do them for myself, I do them as a slot, and that is right up here under create slot. I'm going to do them as a square just because. So now we need to make this bit right here. And what I'm going to do is I'm going to just make a rectangle, and I'm just going to randomly place it. And that's basically it, right? The only problem is, if you look, that rectangle is blue and this mortise is black. And the reason why that mortise is black is Fusion says that this rectangle is entirely constrained because it's based off of this rectangle that was entirely constrained. We started at that origin point, we extended it out, we told it is the mortise length long and the mortise width. And you can't move that at all. It's locked in place. This one though, I can move it any which way I want. I can take the whole thing and just go here or go anywhere with it. But we really want it to be constrained. If it's not constrained, it's not going to update when we change a parameter, or it's not going to update correctly when we change a parameter. We want this line to be, I think we called it meet away. So I'm going to click on that and just type in meet. Yep. So now it is that far away. And look at that. Now it's right over there. So now I'm going to click here and click there. And we could call that one meet as well. And now it is further away. And we want this one to be meat. And we want this one. Oh, we want this one to be meat. And that is looking larger than I thought. So that's 5.8 inches. So right there, so over constrained sketch. Basically Fusion's saying, no, you've got enough rules in place. It is constrained. Don't mess with it anymore. And it says, do you want to create a driven dimension? And what that basically is it's basically just telling you this is 5.8 inches, but you can't change this at all. It's just 5.8 inches. I'm giving you a number, and that's it. So we could even create a driven constraint here or driven dimension there. So we could see that this template is 7.5 inches long and 5.8 inches wide. And that might be, quite honestly, that might be overkill. So let's change that parameter. Let's say the meat parameter, where's that right there? That meat parameter, let's make that 2 inches. And you saw it just zoop, got smaller. So cool. This is very, very cool. What else do we need? We need the fence. And I'm going to create a rectangle, hit R to create a rectangle and just make a rectangle. Now that's blue. It hasn't been told where it is at all. So, I'm going to hit D and let's just say that's 1/4 of an inch wide. And then I'm going to make another one, and I generally like to make this one shorter. And so I base that off of that edge. So it's kind of anchored there, and hit D to make it a certain width. And I might as well just click that first 1/4 inch wide that we made. So they are now related to each other. So now if I change this one to 0.5 inches, they both change to 0.5 inches. We want to place this fence. So I'm going to hit D and I'm going to say from the mortise, not from that edge, because that's where the bushing goes. From the mortise, let's make it offset side. And from the end, nope, hit escape. I had the wrong one selected. Hit D, grab that and that, and we're going to say offset end. So now everything here, except this little blue line, everything here is fully constrained. And, you know, we might as well just cause, and I'm going to say that is 3/4 of an inch wide. And honestly, am I worried about that being 3/4 of an inch wide? If I wanted to hold this whole thing and the board in a vise, and that this extended past the side of the board, that might be a problem. So I'm going to make that 0.5 inches, just so it's a little bit of a nub, but just enough to reference off the end of the board. So we're fully constrained and we have a sketch. That's great. What do we do with that sketch? I just hit finish sketch and I can orbit around, and that's all it is. So we want to make a body, and I'm going to click on that area, and I'm going to hold down shift and click there and there and there. And I could hold down shift and click there, but they're intruding on each other right now. And you don't really even need it. And you'll see in a minute. We need to extrude this out. So I'm going to hit E for extrude. And this template I made 1/4 of an inch thick, and it's fine. It's there's a little bit of a flex to it, and so I might as well just make it 3/8 of an inch thick. And boom, we have a template. And that template is going to give us mortise length by mortise width with this router setup. And boom, we could be done, and we could double stick tape that to a workpiece and we're fine. But we went through the trouble of making that fence, So we might as well use it. And if you look though, that sketch is gone. It's gone. So over here, we've got, this is our body that we made. And our sketch here has gone away. And I can click the eyeball and pull that sketch back. Or I can double click on it if I want to make updates to that sketch. I don't want to update that sketch right now. So I'm just going to click the eyeball to show the sketch. I'm going to zoom in. I'm going to select this fence and this part of that fence too. And now I'm going to hit E to extrude it, and I will go up and it just cut everything out. Like if I hit OK, now I have two bodies because I just broke everything. And Fusion, I'm going to undo that. Fusion is entirely happy with you using the extrude to create the negative of something as much as it is to create the positive of something. And it's a really powerful feature, but at first it takes a little bit of getting used to. So right here, let's select these two bits again, and I'm going to hit extrude, and I am going to, you could drag it away and it is joining. So just to show you, if I drag it that way, this operation turns to cut. Now I could very, very easily change that to join, and that's fine. But for some reason, I've just gotten in the habit of selecting these things. And if I want to, I'll just type in -1 and create a 1 inch offset fence there. So that is 1 inches from the origin. This is 3/8 of an inch from the origin. And we're basically done. I could 3D print this and create a 3/8 inch by 2 inch mortise without issue, without one bit of an issue. But that's not the magic of Fusion 360. The magic of Fusion 360 is the parameters. And we want to create parameters that you can update. And if tomorrow I need a different size, let's do it. So I'm going to turn off automatic compute just for drama purposes. And let's say tomorrow I want a 7/8 inch wide mortise, and I want it to be 3 inches long, and I want the same router setup, but I want it to be 1 inch from the side, and I want it to be 3/4 of an inch from the end. And I hit OK and apply parameter changes. There are some parameter changes. Do you want to apply these changes? Pressing no will clear the parameter changes. Yes, I do. And boom, look at that. Look at that. The whole thing is updated. It's totally different. It's magic to me. I absolutely love that. Let's go back and I'm going to keep automatic compute on now. So let's go and we're going to do 3/8 again, and boop, everything changed. And we're going to do 2 inches again, and boop, everything changed. And the side offset, let's go back to 3/16. And this one, let's do 3/4 to the end. And everything is updated, and we're pretty much good to go. That's it. That's all you got to do. Now I'm just going to select this and go up to File and click 3D print. And these are the settings that I use to get things to my 3D printer. I'm just going to basically click that, and my 3D printing program opens, and it's upside down. So I'm going to click this and put that on the base, and we're pretty much there. Let's just slice that and print it. So this is a large template. It takes 2 hours. Might as well print it. But this 2 hours that I am doing other things. I'm watching a show or cleaning my shop, which desperately needs to be done. It's pretty much magic. So meet you back here in 2 hours with my mortise template, and we're going to see how it works. Okay, so we have our mortise that we cut with our router using this 3D printed template. This technique is super powerful and incredibly versatile. Again, you could download the file and change the parameters to your heart's content, print it up, and you're good to go. In another episode, I will show you how to make a DXF file of this if you have a laser cutter or a CNC and you want to cut it out that way instead. I'm a big fan of making router templates for cutting joinery. There's a couple of considerations though. The upside is this is super easy to print anytime you need it. You could use it, recycle it, throw it away, whatever. I keep my old prints and I'm gonna grind them up one day and reuse the filament, but it's not a precious commodity. Next time I need a template like this, I can just print another one. The biggest upside is, again, super versatile. You can make it any size you want. You can make it do whatever. You could actually go in there and make twin tenons fairly easily if you were working on a big workbench or something like that. It's super powerful. Now, the next one isn't a downside, it's a consideration though. Since you've got this fence over here and you're on the end of the board, you can't just take this one template and go to the other end of the board, because now you were referencing off this side and now you're referencing off this side. You really need to print a second template that is mirrored. I wouldn't mirror it in Fusion 360. I'd mirror it in my 3D printer slicing software instead, but you're going to need to print two of these. So that $1.50 worth of filament really became $3. But this reference face problem isn't really a problem that's isolated to this technique. It's a problem in most of woodworking. If you're referencing off one side for a mortise that you cut on the router table or a hollow chisel mortiser, you really need to maintain that same side as your reference face. With this technique, you just need to print up a second template. Again, it's a consideration, not a downside, because so many other woodworking techniques have the same downside. Editing Ben here. Just don't put this end stop in and you could slide it anywhere you wanted to. You would, yes, have to make a pencil mark like an animal and line it up like a woodworker or something. But it's pretty doable, dude. One downside, though, is that while this template measures up within 4 thou of 7/8, it's very accurate. It's not dead nuts accurate. And I don't know if anyone really does need dead nuts accurate. I don't see this being isolated to a 3D printed router template. And I certainly don't see people measuring, you know, the mortise from a hollow chisel mortiser to see how perfectly accurate it is. Fact of the matter is, in practice, you're going to make the mortise and then you're going to make your tenon to fit the mortise. This technique, I would use floating tenon stock, so I would use the same template on both sides of the joint and use floating tenon stock. I would make it to fit that mortise. That's just the way woodworking works. You fit your tenon to your mortise. But most of the time, y'all realize that, right? So head on over to wooddorking.com and you can get the Fusion 360 file if you just want to jump in there and mess with parameters and print some stuff up. Also over at wooddorking.com, you can download a PDF step-by-step, click-by-click, following through this process. And if you want to try it yourself, if you want to start from a scratch Fusion 360 file, download that PDF and follow along and make the template and learn something while you're there. So this is a really good introduction to parametric modeling with Fusion 360. I think a lot of woodworkers could really benefit from learning parametric modeling with any program, but Fusion 360 is my program of choice right now. Again, head on over to wooddorking.com, download the files, download the PDF. We're going to do more stuff like this. So thanks for watching, and we'll see you next time.